Voyager 1, launched by NASA on September 5, 1977, remains one of the most remarkable feats of human engineering and exploration. It was initially designed for a mission to study Jupiter and Saturn, their moons, and the surrounding space environment, but it has gone far beyond its original purpose. Today, more than 4 decades later, it continues its journey into interstellar space, making it the most distant human-made object from Earth. Its mission, which was expected to last only about 5 years, has far exceeded all expectations, operating now for over 45 years. What's even more astounding is that despite the vast distance, Voyager 1 is still sending back data to Earth. Information that not only helps us understand the outer reaches of our solar system but also sparks new mysteries. One of these mysteries has recently captivated scientists and the public alike. Voyager 1 appears to have made an impossible discovery, something no one anticipated. At the heart of Voyager 1's continued success lies its incredibly robust design. Equipped with scientific instruments capable of measuring magnetic fields, cosmic rays, plasma waves, and other phenomena, Voyager 1 was a marvel for its time. Yet, compared to modern technology, its computing power is astonishingly minimal. It has only 69 kilobytes of memory, less than what you would find in a digital photo. The spacecraft relies on its radioisotope thermoelectric generators, RTGs, for power, which convert the heat from the decay of plutonium-238 into electricity. Over time, the power output has gradually declined, forcing NASA engineers to make tough decisions about which instruments to keep running. But despite these challenges, the spacecraft's core systems remain functional, and the data it transmits continues to surprise scientists. In 2012, Voyager 1 made history by becoming the first spacecraft to cross into interstellar space, passing beyond the heliopause, the boundary where the Sun's influence wanes and the interstellar medium begins. This transition was confirmed by the detection of a dramatic increase in cosmic ray intensity and a corresponding drop in solar particles. It marked humanity's first step into the space between the stars. But while many thought the journey from that point onward would be relatively uneventful, Voyager 1 had other plans. Its instruments began detecting strange fluctuations in the density of plasma surrounding it. Unlike anything seen before, these fluctuations hinted at the presence of complex structures in the interstellar medium, structures that challenged existing models. Then came the event that made headlines. Scientists monitoring Voyager 1 noticed that it had sent back an unusual data packet. It wasn't supposed to be sending this type of information at that time, and when the binary data was decoded, it revealed a pattern. At first, researchers suspected a glitch in the spacecraft's aging systems. After all, Voyager 1 is operating in extreme conditions, and occasional data irregularities aren't uncommon. But upon further analysis, they realized this was something else entirely. The pattern wasn't random, it appeared to be deliberate, almost like a signal or code. Some compared its structure to geometric glyphs, reminiscent of patterns seen in crop circles, while others speculated it might be a natural but poorly understood cosmic phenomenon. The discovery immediately triggered debates within the scientific community. Could this be a sign of extraterrestrial intelligence? Most researchers were cautious, pointing out that nature is capable of producing highly ordered patterns without any conscious design. Plasma waves, magnetic fields, and cosmic ray interactions can sometimes align in ways that create structured signals. Still, the level of order in the data made it hard to dismiss the possibility entirely. Some theorists proposed that the signal could be an interstellar version of a pulsar beacon, a natural but extremely precise cosmic transmitter. Others wondered if Voyager 1 had stumbled upon a region of space where the interstellar medium behaves in ways we have never encountered. Adding to the intrigue, NASA engineers discovered that the spacecraft's attitude articulation and control system, AACS, responsible for keeping Voyager's antenna pointed toward Earth, had inexplicably begun sending status reports through an onboard computer that hadn't been active in decades. This caused the data to become corrupted before reaching Earth. Engineers managed to switch the system back to its proper configuration, restoring normal communication, but the reason behind the sudden shift remains unknown. Some have speculated that an unexpected environmental factor, perhaps linked to the strange signal, might have triggered the anomaly. Others suggest it was simply a fault in the aging hardware, unrelated to the data pattern. But the timing of the events left room for speculation. As news of the discovery spread, the public fascination grew. For many, Voyager 1 has always been more than just a machine. It is a symbol of human curiosity and our desire to explore the unknown. The idea that it could have detected something mysterious so far from Earth resonated deeply. Social media buzzed with theories ranging from scientific to sensational. Some claimed it was evidence of alien contact. Others believed Voyager had passed through an ancient remnant of a long-lost civilization. While these ideas remain speculative, they reflect the sense of wonder that Voyager continues to inspire. In reality, the mystery may have more to do with the nature of interstellar space than with extraterrestrial intelligence. The region beyond our solar system is not empty. It is filled with plasma, dust, and magnetic fields that can interact in complex ways. Our understanding of this environment is still in its infancy. Voyager 1's instruments have already revealed that the density of interstellar plasma is higher than expected, and that it fluctuates over time. The unusual signal could be the result of an interaction between the spacecraft and one of these plasma structures, perhaps a shock wave from a distant supernova or the boundary of a dense interstellar cloud. If so, studying it could give scientists valuable insights into the structure and dynamics of our galaxy. Nevertheless, the possibility of something truly extraordinary lingers in the background. Scientists are careful not to jump to conclusions, but they also recognize that part of the scientific process involves entertaining unlikely possibilities, at least until they can be ruled out. That is why teams continue to analyze the data in detail, using advanced algorithms to look for repeating patterns or anomalies that might reveal more about its origin. At the same time, they are working to extend Voyager 1's operational life for as long as possible. This involves carefully managing its dwindling power supply and making strategic decisions about which instruments to keep running. The clock is ticking. Voyager 1's RTGs lose about 4 watts of power each year, and eventually, the spacecraft will no longer be able to power its instruments or maintain communication with Earth. NASA estimates that we may be able to keep receiving data until the early 2030s. After that, Voyager will drift silently through the galaxy, carrying its famous golden record, a time capsule of sounds and images from Earth, as a message to any beings who might one day encounter it. The thought that the spacecraft could travel for billions of years, long after humanity is gone, is both humbling and awe-inspiring. As for the impossible discovery, it remains an open question. Perhaps future analysis will reveal it to be a natural phenomenon, one that simply looks unusual because we have never encountered it before. Or maybe it will point toward something more, a hint that we are not alone in the universe. Either way, Voyager 1 has once again proven that exploration is as much about the questions we uncover as it is about the answers we find. Even in the vast emptiness between the stars, there are still surprises waiting to be discovered. The story of Voyager 1 is a testament to human ingenuity and perseverance. When it was launched, the internet didn't exist, cell phones were unheard of, and most people had never even seen a personal computer. Yet this small, distant probe continues to connect us to the cosmos, sending whispers from the edge of the sun's influence. It reminds us that exploration is a journey without a final destination. There will always be more to learn, more to see, and more to wonder about. In that sense, Voyager's mission is far from over. Its discoveries, both past and future, will echo for generations, inspiring those who dare to dream of what lies beyond the next horizon. And perhaps, in the faint hum of its radio transmissions, there is a message, not just from the spacecraft, but from the universe itself, telling us to keep going, to keep searching, and to never stop asking questions. Whether the strange signal turns out to be an alien greeting, a quirk of interstellar physics, or something entirely unforeseen, it serves as a reminder that the universe is vast, mysterious, and full of possibilities. Voyager 1, our silent emissary among the stars, continues to prove that sometimes the most unexpected discoveries are the ones that change how we see our place in the cosmos.